Well, welcome back, everybody. Let me get my power plugged in here. And welcome back to my bench. And today on the bench we have a little, just a simple little time waster project for fun. And I thought maybe this would be something that may be interesting to those of you who are getting into radio a little bit. It's a nice little project that you can do pretty simply, and gives you an opportunity to learn a little bit about how radio works. So if you go on to eBay or you go online, Alibaba, or quite a few different places, Amazon, they have these little kits you can purchase, and there's different ones. This is one of them that you can build your own AM, FM, sometimes shortwave, sometimes just AM radio. You can see comes with a bunch of little components. Comes with the circuit board. Okay, and it's all marked out and everything. And it comes with a little dial scale. And comes with some directions that aren't very easy to understand, but really the most important part here is the component list and the part number and the little layout up here. Okay, so don't worry. This looks like it might be more complicated than it is, but it's really not that bad. So what I'm going to do is instead of skipping through a lot of this, we're actually going to look at some ways for identifying these parts for people who are new to this, who aren't really used to working with these types of things, and how to properly solder them into place. And then we can look at some of the things that we can do to adjust it if necessary, and so forth. Remember, if you notice, these little kits from China don't really come with a whole lot of instructions, and what instructions there are in Chinese. Now, I'm sure those of you who are enterprising computer people could scan this in and then do a Google Translate and then be able to get an idea of what this is saying. But we're going to try to do this on our own here. So for those of you following along, hopefully you'll be able to follow what I'm doing and be able to have success in getting your own radio working. Now, I've never built one of these yet, so we're both going to learn together here if these actually work or don't, or what some of the pitfalls may be. These can be purchased online for under $10 American, and with free shipping usually. Again, there are different versions. This one, if you look, has an actual linear dial. I purchased another model. It's a little bit larger case, as you can see, and it has a round dial, but they're all basically similar in design. And no matter which one you buy, they all pretty much work the same way. So first thing we're going to talk about is when you first open one of these kits, what do you want to do? And one of the things I like to do is I like to have some sort of a tray. This actually, I know you see me use these sometimes. What these actually are, if you see the little holes in the side, these are little, these come out of a computer case. Some computer cases come with, the hard drive trays, and these are just dummy trays that take the place of a hard drive. And whenever you want to put a hard drive in that case, you would remove this plastic piece and throw it away, and you'd put your hard drive in. But I saved these because when I looked at them, they're perfect for holding parts, and I probably have 5 or 6 of these things. So the first thing I always like to do is I like to go through all and inventory my parts and get them out of the little package. and put them in a little tray or something. You can use a little cup or a little dish or any little container, so that you don't lose these pieces. Now what you're going to find is they're very tiny, especially some of the little screws and the little capacitors and so forth. You see all the components in there. And by far, for those of you who are new to electronics, the most difficult thing you're going to find is identifying the capacitors and the resistors and some of the little components in there. So what I'm going to try to do is help you to understand what these are and how to identify them, and show you some little shortcuts that we can use in the event that we do not know or can't figure out by the color codes what these are. Okay, and I'm going to try to do this all with inexpensive test equipment and so forth. The only good test equipment or piece of equipment I'm going to use is my soldering station, my Hacko. But you could do this with just a inexpensive, plug-in ceramic type soldering iron. I just like the temperature controlled because the tips are smaller and it's just a little bit easier to work with. Does a little better job, but they all work fine. Okay, so let's get some equipment out and we'll be right back. Okay, if you're just going to be getting into kit building or building one of these little radios, one thing you're going to really need, you don't need any fancy tools or anything. You'll need a decent soldering iron. And you can pick up a little pencil type, ceramic pencil type, very, very inexpensively at any hardware store. And another thing you'll need will be a multimeter. And you don't need a really expensive, like a fluke meter or something like that. These are a lot of money and they're good if you're going to really get into this seriously, but for just checking low voltage, if you're not going to be working with vacuum tube equipment or mains voltages a lot, you can get into these. Now this one here, this is a very high mass produced meter. It comes in some different case colors, has different names. I picked this one up at a hardware store in the United States called Harbor Freight. They sell a lot of Chinese equipment, low cost, but these can be purchased. I've even seen these given away as like with coupons, to get you to come into the store. When they sell them, they're under $5 sometimes. You can order them on Banggood has them, eBay, of course, Amazon, a lot of places you can get these online, and they're $5 or so with a set of probes. And it'll do the basic things you need to do. It has a little transistor checker. It'll check volts and ohms and amps. For a little bit more money, you can go onto those same sources and buy something similar to this, which gives you a little more features. It's a little more substantial how it's built. It also can test frequency, temperature, capacitance. It has a little capacitor meter. Has manual or auto range, and this one's even true RMS, and these can be purchased for $20 to $30, and they're decent for for just being on your bench, for being new to the hobby. This would be a great thing, and this is what we're going to use. Okay, it comes with a set of probes, and you're going to find that this comes in very handy when testing components, especially with these little radio kits. When we look at some of these parts, and let me zoom you in a little bit, you can see just how tiny these parts are. And a lot of these resistors, these little 1/4 watt ones, can be very difficult to see the colors and see the stripes. Come on, focus. So you could see right there. It's very hard to tell. And if you can't tell what it is, that's where your meter is going to come in handy. You can set your meter to ohms, and we can take this and just measure it, and you can see This one's reading about 4.7, 4.8 ohms, and that's what it is a 4.7 ohm resistor. Okay. Here's a 2.2K. Alright, if you can't see the red for 2.2K, or you don't have the charts memorized yet, you don't want to look it up, you can see, you can test it, and you have about 2.2K. Okay, and remember, it's not always going to be exactly 2.2K. It's plus or minus a little bit based on the tolerance of the resistor. Most of these have a gold band at the end, you can see, which means that they're plus or minus 5%. Okay, so anyway, and now here's the thing that is going to confuse you. Capacitors here, these are little ceramic, and they come from China, and they are included a lot with these little kits. And if you look inside here, come on and focus. Let's see if we can get this. There, see what it says? 104. So let's stop here and take a look at something for a minute. If you look at a ceramic capacitor, this is how it's supposed to be. So you have your first digit, your second digit, and then your multiplier, which tells you how many times. This would be 3 zeros, 4 would be 4 zeros, and so forth. Okay, so basically this would indicate the capacitance. All right, so for instance, if we go to this little chart here, in this instance you have 473, so a 4, a 7, and a 3 would be times 1,000, and that's measured in picofarads. So it would be 47,000 picofarads, okay, which would be 47,000 picofarads, which is 0.047, I believe it is. I'm going to have to, if I'm wrong, guys, you can go ahead and correct me. That's okay. I'm just going off the top of my head. Now, that usually means it's pretty easy to figure out what a capacitor is value-wise just by looking at the number. So in this case, let's take a look. It would be, come on, 104. Is that what that says? 104. I'm looking through the camera. All right. So with that in mind, that would make this, and bear with me, you'll see why I'm doing this here in a minute. 104 would be a 1, a 0, and then times 1,000. So that'd be 10,000, right? Picofarads. All right. Now, 1 picofarad, okay, equals 0.000001 microfarads. So 10,000 of those would be up here, 0.01 microfarad, right? Am I right? 10,000. 10,000. 10,000. Okay, so it would be 0.01 microfarads. Okay? So, that being said, if I put my little meter on capacitance and I measure this capacitor, what's it say? 69 nanofarads, okay? And 69 nanofarads would be 0.069 microfarads, right? So, what in the heck is going on with this? So maybe I got a bad capacitor, huh? So let's look at another one. This one is also a 0.069 104. Again, should be 10,000 picofarads or 0.01 microfarads. So, what do we have? Again, 63 nanofarads. Okay. So, maybe my meter is no good, right? So let's take one of these little component testers and let's put this in it. Hit the test button. Again, 61 nanofarads. What the heck is going on? Okay, so let's take out the big guns here, huh? And we're going to turn this on. And this is a very expensive piece of test equipment. Alright, so it is very accurate. So we want to go to capacitance. And we're going to plug this in. And see if it reads. Ah, I don't know if it'll go in here. These are so tiny. And look at that. What is going on here, guys? Okay. Maybe I'm not making good contact with this. Let's go to the sun core. Right? This is supposed to be 0.01 microfarad, according to that number, correct? Alright, let me take you out of here. What does this say? What the heck? 60,000 picofarads. This is not making much sense, is it, guys? Now, just so you know that I'm not crazy, I have, let's see if I can find, I don't think I have any discs that size. But what I'm trying to say here is that this isn't the first time this has happened to me. I know I'm wasting a lot of video on this, but I don't want you guys to get lost the first time you check this out. These markings aren't always following the normal values of the capacitors. They just aren't. And I've seen this before in some of these imported kits. No matter how you slice it, I mean, they're all going to read the same. I mean, I can go down the list here. I've got 1, 2, these are all saying 104 on them. 3, 4, okay. And you can see they all read the same amount. If I can get the probe on there, see? They're all between, you know, around 70 nanofarads. Okay? 60 to 70 nanofarads. And what the reason I'm showing you all this is if you get your capacitor meter and you look up on the chart what it's supposed to be, no, your meter's not bad. Sometimes they just don't follow that value. That's like some sort of a I don't know, factory number or something from the manufacturer. And if you look on the bill of materials that comes with these little kits, they don't tell you what the actual value is. They only show you the number, the part number, 104. See that? Let me zoom you in. 104. Okay, that's it. It doesn't tell you the value. So once again, don't be alarmed if the components, the capacitors, those little ceramic discs, don't match what the charts tell you. Okay. If you notice, there's no tolerance, there's no voltage rating, there's no temperature coefficient, nothing, just the number 104, and that's it. So again, I wanted to show you all that because this could throw you for a loop a little bit. Follow the chart, what it says in here. All right, do not worry about what your meter says, because that number may not necessarily be an actual capacitor code. Okay, so with that said, let's get to work and see how we put this thing together. Okay, so we have this little PC board, and we have the little diagram, and they're showing you the foil side, the solder side of the board. But and they actually have the components marked. Okay, so this is actually pretty convenient. We also, if we flip this over this way, we can see the parts right here silk screened onto the top part of the board. So we see from both sides what components belong where. Now when I start placing the components on here, I always like to start with the resistors first. Resistors, capacitors, and then resistors, diodes, capacitors, things like that. Basically the components that are the lowest profile on the board, and then work your way up. You're going to have to take note of a few things here. Number one, there's no instructions how to assemble the mechanical parts like the knobs and the dial indicator, and we'll go over some of that here a little bit later in the build. One of the last things before I start putting big components on will be these two coils. Now, how do they identify these coils? They don't have any markings on them, as you can see, and there's no way of knowing what they are. Okay, well, here's how they do it. If you look on the board here very closely, you can see this one is called 8T5, see there? And this one is called 7T5, all right? And basically, those should match. I believe they're talking about how many turns the coil is, all right? And we're going to try to count that because, once again, I'm not sure. So if we look here, we'll try to count the turns. So we have 1, 2, 3, 4, 5, 6, 7, 8. So that's an 8 turn right there, is what I believe that is. And actually that's probably 7 turns, because really it's not, this one's not a full turn, that's half a turn. So this would be your 7.5 turns. Then here you have a 1, 2, 3, 4, 5, 6, 7, 8, 9. So 8.5 turns. Now, strangely enough, where it says 8T5 here and where it says 7T5 here, it would lead you to believe that the larger coil is here and the smaller coil is here. But if you go by what they're calling them here, okay, then actually the shorter coil goes in the longer silk screen. And again, we don't know I mean, if they have this marked correctly or not. But I'm going to put them based on what they're calling them here, even though the smaller one fits where it says, you know, the 8T, the 7T fits better in there. And when you go to the 7T, the 8T fits better in there. So I'm not really sure, you know, because really if you look at this, they don't fit. And they do fit the opposite way. So these are the things you're going to run into with these Chinese kits, unfortunately. And let's see. And of course, all of this, L1 and L2, does not make much, you know, it doesn't give you much information. So I'm not sure. We may have to experiment with that once again. If I look over here, there's your 7T5 and there's your 8T5 right there. Okay. And again, we don't know. Obviously, the one with 8 turns has a wee little bit more inductance than the one with 7 turns. Unless they are not calling it, unless the T doesn't, you know, I believe that means 7.5 turns of wire. Again, I'm guessing all of this. So these are things we're going to run into as we're putting these together. Okay. Again, I didn't open this prior to this video. We're kind of learning together. And I want you to see the process that you have to go through and some of the things you may run into with these cheap kits. You know, you can buy a radio kit from some other companies, especially some of the Japanese companies and American companies. They're a lot better quality and they have really, really concise instructions, but they also cost a lot more money. So that's why we're going to have to be pretty careful with this. The other thing is, one of the integrated circuits on this is surface mount. And that's going to be a bit of a challenge to put on. You can see. And it's really strange because they're showing the IC. And let's see here where they're putting that. There it is right here. It's on the back of the board. So this will have to go this way. This will have to be very delicately soldered on there as well. And that'll probably be the first component I place. These are really hard to do when there's a bunch of components around it. So I'll show you how to do these. And again, if you don't have a really thin tip on your iron, this is going to be pretty difficult. Okay? So let's see how we do it. Okay guys, this is going to be a little bit difficult because I'm actually working around the camera here. But what I like to do is I like to get one pin started. And I'll do that first of all by putting a little drop of flux onto the pin here. Okay? And gotta kind of get that. We'll put a little drop of flux on there, like that. And then we take some very fine solder and just kind of lay it on there, just like that. Okay? Make sure you have a very clean tip when you start this. Alright? Now, if you look at the orientation of this here before we start, there's a little dot on the front. I hope you can all see that. And that dot, you can see the little notch on the silk screening. The dot is the front of the chip and also signifies pin 1. So we want this chip to go this way. You can put it in upside down. Be aware of that. Okay? So the first thing you want to do is get this thing lined up as closely as you can and hold it down right here. You see how we have it. And make sure all your pins are properly lined up. Then we come in with our iron. Wait till it's warmed up here. And we just go like that. And now it's tacked down so that we can go ahead, and if you look, all of the pins should be properly sitting on the pad. Okay, and if you need to bend it just a little bit, you can. Then I like to go over to the other corner, which is this corner here, and I'll put a little dab of solder on there. And there you go. Simple as that. Now we can go down the line and we can do each pin. Now this is very tricky because you can very easily build a little solder bridge if you don't take your time. Okay. Different people have different methods for doing this, and it's just a matter of what you're most comfortable with. Some people will pre-tin all of the pads and do them that way. I also have a bent tip that I'm not using on this, but the bent tips are a lot nicer to get in here with if you have one. But I'm just showing you on this, you can do it with just a small pointy tip. Then we're going to flip this around. We're going to do the other side. Oops, am I still in the video here? Yep. Okay. Now, I'm looking around the camera, so I really didn't see how well I got it. But let's get it up here close. See if we can get it to focus. Oh, hold on. Let me change my focus here for a minute. There. And let's see. See if it'll autofocus for us. There it goes. And it looks to me like we got a big blurry mess. Here we go. Yeah. Okay. So we can touch that up a little bit, and what I'll probably do now is put a little drop of flux on the ones that don't look good enough, and then I'll touch those one more time to get them to flow properly. Alright, so let's go back down here. And let's zoom back in a little bit. Has a hard time focusing. There we go. And we'll take a little drop of flux. And we'll take our light here. Just a little bit of flux down here. And we can always clean that back off. There's one. There's one. And that's looking pretty good. Okay. And there you go. Bring it back in here. Come on, focus. Focus. Yeah, there we go. How about that? And you can see once again, it looks a lot better. So that's it. So that part is mounted down. And that's how you take care of those little surface mount chips. Again, it takes a little bit of experience. Make sure you regularly clean the tip. You see how clean I keep this tip on this without burning myself, hopefully. But you can see I really try to keep the tip very, very clean. Alright? I use this tip all the time. And just by kind of brushing it off, and you can see, you can buy these online. They're little brass fibers here, and they clean your tip. You can also use the little tip sponge, you know, the water sponge. Those work also. But the idea is make sure you use a clean tip and clean it often, because any of that tarnish or any of that scale or any old solder that gets onto the tip will just mess those little tiny pins up to the point you can't fix them. So that's it. And do not dwell too long on it. If you do, you might burn those tiny little traces on there, the little pads. Okay, let's move on to the next thing. The next thing I want to do is the resistors, and as you can see, they're marked in how many ohms they are. So a 1K5, for instance, right here would be a 1.5 K ohm or 1.5 thousand ohm, 1500 ohm resistor. Now, if you do not know the color codes, I suggest this is a good time to learn them. You can download a color code chart online, or you can download little calculators that you type in the resistance and it'll tell you the colors, or you type in the colors and it tells you the resistance. Lots of different ways to do it. It's a lot easier if you memorize it, okay? So if you know that 1.5K is going to be, you know, brown, green, red, it's going to make it a lot easier for you to be able to look. For instance, here we go. Here's a brown, green, red. And if you're not so sure of yourself, once again, get out your little meter, turn it on to ohms, and measure it. There you go, 1.47K. Alright, it says K ohms up here. Watch again. Look at the meter, and you can see it says K ohms up in the corner here, 1.47. So we know this is a 1.5K resistor. Okay, and what I'm going to do, and I'm not going to show you every single resistor, we're going to do one resistor, and then just you know that that's how I'm going to do all of them. We're going to take the resistor. You can get fancy little resistor bender things, little bending jigs. You can use a pair of pliers, and you can make really nice bends. Or in this board, they're bent all the way down to the actual case of the resistor. So you just fold them over, and then you place them into the holes over top of its little marking. You can see just like I did. So there's your 1.5K. Push it down in, and you can see it just fits in there. Alright, and fold it this way and fold it that way, and just kind of fold them over a little bit. Now you're going to have to make some choices now. You can solder these in, but if you notice, you have multiple pins all connected, and if you're not really careful, you can cover over those holes before you put the components in them. So you can do one of two things. You can tack down this side right here and then wait till these other components are populated to do them all, or you can be very careful and just make sure you don't get any solder over the other holes there. Okay, so I'm just gonna go ahead and do do it now. I think we can get this, and we can always clear it off if we don't. Now again, this is rosin core solder, so you shouldn't need to put put flux on everything. I just did that to get it to flow better on those pins on that little IC. Okay, so there you go. Done. Now, once you do that, another thing you're going to want to invest in is a nice, good quality pair of wire cutters. And you want these really flush cutting ones that are sharpened. You have to watch the other type, because some wire cutters, and I don't know if I even have a pair here. Well, here's a big set. You can see the bigger ones that are made really for big wires. If you notice, they're chamfered in this way. They can't cut flush. They'll always leave wire sticking up. Whereas these ones, if you notice, are completely flat on the bottom, and they'll cut off. And you can buy these, once again, very inexpensive. You can buy them at any hardware store or whatever, electronics store. And there you go, you trim them off. And we may need those extra wires for jumpers later, because if you notice, there's a couple places here where they want you to put a jumper. See where it says J? That's just a straight piece of wire. That J stands for jumper. Okay? So, I'm going to go ahead and finish all the resistors and the jumpers, and then we'll be back. Okay, I'm working on these resistors, and I did want to bring one thing to your attention. Anytime you see the resistor layout this way, that means the resistor is to be put down flat like that. But in a few cases, you see this little circle here, see it? And it says 22K. And there's another one here, 33K. And here's another one here, 1K. In the instances where you're going to see that, you're actually going to take the resistor and you're going to place it in this way and fold over this lead, okay, like so, and you're going to place it into the board this way. So it's supposed to stand up. And they do that to fit it in there. Sometimes they can't lay it down. So just so you know that, that's what that is. Don't let that throw you off. Okay? Okay, and 15 minutes later, there's all the resistors. So the next thing we're going to mount on there is I'm probably going to go ahead and do the integrated circuit, because that should be relatively simple. Okay, and just for giggles and grins, let's look this up. This particular chip is a TDA, let's see here, TDA 2822M. Now usually these TDA chips are amplifiers or something, but let's look on the schematic and see if we can get a clue. And there's the 2822, and if you look, what's it connected to but your speaker and headphone jack. So this is going to be your audio amplifier chip. Okay, so usually chips that, these TDA type chips are usually audio amplifiers. This 9088 that we put in there is actually your tuner chip. It's basically, we'll look it up, but usually this here is an AM tuner chip right here. So this is a tuner on a chip, and if you look, they're called radio on chip. And actually, I have a whole bunch of these. Here's one out of my bins, and this one's a 7642. Is that the same? Yep, same chip. Basically, that whole chip is an AM radio. You don't need IF stages. You don't need anything like that with them. So let's look at these two chips, because they're kind of interesting. If you notice, there are no IF cans. There is no slugs to tune. There's no little transformers. So how do they do that? Let's take a look. Okay, so first of all, let's look at this 7642. If you notice, it's only 3 pins, and as I showed you, it just looks like a little transistor, doesn't it? And this actually, section right here, is your AM, and it ties into this chip, because this, you're going to see this chip actually has accommodation for an AM section if you have an external tuner. Now, when we look at this, here's an equivalent circuit of what's inside of that chip, and as you can see, there's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 transistors, resistors, and capacitors in there. Okay, and they have a suggested equivalent or application circuit, which is here. You have your little tank circuit right here and your little antenna, and then your tuning capacitor would be here, and that's really all it needs. Everything else is done internally here. So it's a pretty slick little circuit. Now, instead of using the a little transistor amplifier, excuse me. Okay, sorry about that. I had to answer a phone call. So anyways, you can see this radio doesn't use the transistors like this with the 32 ohm speaker, because it actually comes out of the output of pin 3, goes down here, and you can see it switches into this TDA 2822 integrated circuit, the amplifier chip. So there you go. Okay, now the next chip is this 9088 chip, and it's pretty interesting because it's an FM receiver. It's mono only. It does not have a multiplex circuit or anything, but it does have pretty much all the stages that you need from the antenna to the audio output. So basically, it's an entire FM receiver on a chip. And it has a mute circuit that you can use. It'll do search tuning with a varicap diode. Okay, a varicap diode is a diode that has a capacitance that changes when you apply a voltage to it. Okay, and All American 5 Radio's YouTube channel, if you go check him out, All American 5 Radio, he does a little, I think he does do a video on these varicap diodes, and it's very, very interesting how he demonstrates it. So I suggest you check that out if you want to learn more about that. It has an AFC circuit with and you can use mechanical tuning with a external capacitor, which is kind of what they're doing here. And it has power supply polarity protection, so if you hook the battery up backwards, it won't damage it. And it will run on very low voltage, so it's very good for portable battery operated radios. If you look, here's a block diagram of pretty much what's going on inside here, and you see you have your variable or your voltage controlled oscillator, you have your mixer circuit, okay, and that's basically, this is working like your local oscillator. You're mixing it together, and then in here is your limiter circuit, which strips off the AM, okay, just like any other standard radio circuit out there. You have your filters, and then you have your FM detector or demodulator. So everything is here, okay. You have a muting circuit, you have a search tuning circuit, all built into this little 16-pin surface mount chip, okay. And it can run on, like I said, down to 1.8 volts. They're recommending 5 volt. And you can see some of the different parameters here. Okay, and you can see it's a fairly decent little radio. All right. And here's your typical application. And you can see with a very minimal amount of components, you can have yourself an FM tuner. So there we go here back to our schematic, and you can see they pretty much stuck pretty close to the reference, your suggested application. You can see there's a few differences, but for the most part, there it is. You can see pin 5, they're using a little bit of a different oscillator there, okay, but similar. Okay, so It's a very easy, simple circuit to build since everything is basically contained in the ICs, and the bonus is you don't have to tune any coils. There's no IF coils, there's no RF coils. Everything's pretty much handled for you. The only variable capacitors on there is your tuning capacitors, which would be this one for the AM and this one for the FM. And that's really all you have. Okay, and you have your two coils, your AM bar and ferrite bar antenna, and that's pretty much it. So this is a very simple circuit, and that leads us back to where we were. And we're going to go ahead and we're going to mount the audio IC right here, the TDA 2822. Now if you notice, something that you guys may run into, and if you're new to this, whenever you get an integrated circuit, usually they come with the pins kind of flared out at a slight angle like that, okay? And that's to kind of give tension on them when you put them in a socket. But if you notice the way the pins are drilled in here, they don't quite fit, okay? Now, you can kind of, you know, try to do this, but what I like to do is, if you have a really flat work surface, you can kind of take this chip and just kind of roll it that way, and then take it like this and just roll it that way, and that's just going to straighten those pins out a little bit so that it's going to be easier to mount them in these holes. And you can see they pop right in now. It's just a little tip to help you handle that. Then when you put this in, just take two of the corners, okay, and you can fold one corner over here and the opposite corner this way, and that'll hold the chip in place while you solder it, okay? So now I'm going to tack these in the same way I did the resistors and everything else, and then we'll be back. Okay, next we're going to tackle these capacitors. And of course, just like resistors, these little ceramic capacitors are not polarized, unlike the electrolytics that we're going to do afterwards. Very simple on this particular kit, okay? You just look at the number that's on the silk screen and you match it to the number on the capacitor. Once again, if any of you out there, you know, I'm being honest here, I don't understand why some of these caps have these numbers and they don't match the original code. So if any of you know that there is any type of code to this, I would be forever grateful if you would post it in the comments section of this video to help us all out. Anyways, so what we're going to do is we're just going to take these capacitors. There's a 104 right here, and we're basically going to take a 104 here, and we're going to poke it into here just like that, bend the leads a little bit and tack it in. I'm going to go ahead and do that, and then when we get those all mounted, we'll be back. Okay, all of the ceramic capacitors are installed. Now, a couple notes for that. You want to keep your lead length short on the capacitors. In other words, even though they have longer leads, you don't want them standing way up off the board. You want them to be kind of almost flush to the board. You know, a lot of that can cause problems in RF circuits if you make the lead length too long. Now, the next thing we're going to mount is the electrolytic capacitors. Now, unlike ceramic, electrolytics are polarized. They have a negative lead marked by the little minus with the arrow and the shorter lead, and then they have a positive, which does not have the minus sign on it, and it always has the longer lead. Okay. Now, on the circuit board, they tell you 100 microfarads, but they also show you that the blackened area, the shaded area, is the side that connects to the negative. So in this case, I would take the short lead with the negative sign and put it into the shaded hole on the silk screen, just like this. Okay, and we're going to mount that flush to the board, and just like the other ones, we're going to solder this right down. Now I'm going to put the capacitors in, the electrolytics, and then we'll be back. Alright, we're all done with the capacitors, and next I'm going to mount the rest of these small components here. And last but not least, I'll put the coils on. And after looking a little more carefully, if you notice this 8T5, there's actually two holes here. There's one here and one next to it right here. You can kind of see. So actually, if I use this hole and this hole, these two are tied together underneath. If you look underneath here, you notice they're connected together. So I think if we put it in this way, that 8-turn coil will fit in this one. And that 7-turn one will fit up here, although we may have to move it a little bit. Now, one word of warning, these coils will change their frequency if you separate or squish together the coils. If you notice, these coils right now are very tightly squished together. And I have a feeling if we mess with those will could affect things like the dial scale accuracy and things like that. I'm not sure, but that's definitely a possibility. So we're going to keep them together for right now, and we're going to see how this thing works once we first power it up. And then we always can tweak it by adjusting the width of the coil distance. Alright, so we're going to put this all together, and once I get the rest of these components mounted up, we should be ready to go. Okay, so we're back. We have almost all the components mounted up here. Everything was pretty simple. I mean, like I said, I put the coils in as we discussed. I got the switches, the potentiometer, and this little jack here. And if you notice, it's a little bit crooked, but that's just the way the holes were drilled, so hopefully this will not be a big problem. It's not that far off, but it's on there nonetheless. Now, I stopped right here because I wanted to show you all something. This tuning capacitor at first may throw you off because technically you can mount it either direction. And of course, it's pretty important that you get the correct, get it lined up correctly, because 2 of these adjustments are for FM and 2 are for AM. And hopefully, I'm hoping these are all pre-aligned at the factory. I doubt it, but if we have to align it, we'll go through it and I'll kind of show that to you. But if you notice, there's one wide tab and one narrow tab. Okay, so you get up close here. And if you look on the board, there's a wide slot and a narrow slot. So basically that shows us, and you have to really look closely because they're not that much different. But if you notice, this narrow slot fits in here, the wide slot does not. Okay, so this is how it goes together, right like that. And since you're going to be tuning this is going to get a lot of force on it. So these mounting tabs need to be bent over to give it a little bit extra structural stability. So you just take a little flat screwdriver and just very gently, take your time, there's no hurry. You just come over and bend that side over, and then take this side and bend this side over just slightly, like that. And that kind of gives it a little more strength. And then we'll solder this on, we'll tack these 4 pins, and we'll be all set to go. Alright. And then if you notice on the back of the board, there are some pads here. There's AM, and antenna. Okay, so you have your FM antenna, your AM loop antenna, or ferrite antenna goes in there. And these all kind of go in from this side. You also have these little pads that don't have holes on them. So there's your battery plus, there's your speaker, and this one down here is your other speaker. It's hard to see because, but there's one there and one there for your speaker. And then there's your, like I said, your AM antenna, your FM antenna, and then your battery. So your battery power plus is here, and your battery power negative, I saw it a minute ago, is right here. And it's connected to the switch, which is on the potentiometer. So this is actually a switched potentiometer. You could see the little tiny switch in there. Sorry, I'm moving off camera, ain't I? So there's your pads. Okay, and that's how we're going to tack our wires on next. The antenna will go last because it's very thin wire and it will come apart if you're not careful. So that'll be one of the last things we attach. So let me get this on, let me get the wires on, and we'll be back. Okay, so we have the tuning capacitor in. We have the potentiometer put in, and I just noticed that this is sitting up a little bit proud here, so I'm going to have to reflow these joints here and push this down flush to the board. And basically the next fun part is going to be the tuning capacitor. The tuning dial is kind of a unique thing on this thing, and that is that it consists of this little pointer with this little plastic flexible strip, and the idea is as you turn the tuning capacitor, it pulls it closer and further. See, like that. And this in turn rides inside of the case, so it would look something like this. Let me see here if I can do this the right way. I think I got it upside down here. So this goes in like this, and I'm figuring this out as I'm going along too. There's no instructions. I'm sorry, this part goes in like this. I had it right the first time. So you put this in like so, and then this kind of sits inside here like that. And when it's all put together the right way, the screw would be holding it. As you wind this, it pulls the dial indicator back and forth. It's kind of a neat little thing. I've never seen anything like this before, but I kind of like it. The only problem is we need to make sure that when we put this on, we put it on with the capacitor all the way the correct direction. In other words, if we put this thing with the capacitor wound the other way, you won't be able to turn it, because it'll already be at its end stop. So basically what that means is we're going to try to get this lined up correctly the first time. If not, we may have to take the little screw off, turn this capacitor 360 degrees, put the knob back on, and try it again. So that's what we're going to do now. The first thing I'm going to do though is straighten this little thing out. I don't know how, it must have moved when I was tacking it in. Okay, so let's work on that. Okay, so this battery clip just slides right down into the slot and kind of just locks in. You just push it in, slide it down with a screwdriver, and then this just attaches, and you can see what I was talking about here. You can just kind of see up inside there, and when you turn the tuning dial, it just unwinds and winds around that little knob wheel. And there's your on-off volume. Here's all your wires. Now this screw holds the top, holds the board to the to the case, and then these three stay out, because if you notice here, here, and here, you have your three screws, and those kind of hold that down. So now we have to solder the terminals onto here, and then you have to put them on before you put them down in here, because they have little pins. You see these little latch pins? So I don't know if you can see that or not. So once you push these down, they don't come back out. So we have this one for the positive terminal, and we have the little spring for the negative terminal. and we'll tack those on. I don't want to melt this plastic, so we will put these on here prior to pushing them down in there. Then we have to tack the speaker in there. Now the speaker, I noticed when you put it in there, it doesn't really clip in as per se. So I think the only thing that holds it in is the battery case, or you could put a little dab of hot glue in there if you want, and that would hold it in as well. But we'll see how that goes. And of course, I forgot to put the little slider over top of the switch. I think that clips on from the outside here. So no harm done there, no harm, no foul. And then last but not least, we'll attach the antenna. And it goes down here somehow. I think it goes onto the case out here. And you can see it goes through this little slot. And you can see there's a it's like a non-wood screw. It's like a little tiny machine screw. It goes in there. And again, I'm going to try to tack the wire on there first. Usually what they do is they give you a little terminal strip that you can attach in there, but I don't think they did that on this one. So we will have to let's see, we'll have to figure something out for that. But this might go in here, so I don't know. I have this extra piece too, and I have to figure that out, what it goes to. I'm sure it'll be clear here in a little bit. That's the problem when you don't get... Oh, I know what that is. That's the holder for the bar antenna for the AM. And that clips in here someplace as well. We'll take a look at that here. I think it slides down in here on this section, and the antenna actually attaches down there. So, okay. We'll be back. Okay, we're getting closer now. We have the battery terminals on. We tacked the wire onto the antenna and screwed the antenna into the case. The radio is pretty much all finished and ready to test out. We'll just have to put some batteries in it and put the case together, and it should be ready for a tryout. So let's do that, and I'll be right back. Okay, we got the case together. We have 2 fresh batteries put in there. I do not have the faceplate on because I don't know if this is going to work. So let's see if it comes on. Well, there's a good sign. The light came on. Well, I hear a noise. It's set on FM. Oh, that got louder. You're not going to get much down here in the basement. Okay. Well, we're not going to get much in the basement for that. Let's check AM. There we go. Well, what you're hearing is my little radio station in here, and it's kind of overpowering everything, but the radio does work. Amazing. First try. Now, I'm sure once we get the dial on, we can kind of look and see, try a couple different things with the signal generator and see how accurate the dial is. And then maybe, we could adjust those trimmers on the back of the tuning condenser, although it's not necessary. If you wanted to do it and you don't have a signal generator, you could just tune in look for a station that you know, the strong station that's local. If you know the frequency, put your dial on that frequency and then adjust those two little trimmers on the back of the tuning condenser until you had, get right on top of the station. So, well, this was kind of interesting. Definitely was a challenge because of lack of instructions and because of the cheapness of how these things are built. And let's see if we can snap that on there, just like that. Okay. But that being said, it makes a functioning radio, and it was only like $5 or $6 or something. So, yeah. So let's put the dial on it, and let's just turn on the signal generator and see what it does. Okay. So the only thing we can get here, as long as my radio station is running, is that station. So signal rejection, not very good on these. And that's to be expected. Those little radio on chips are not very good. And this is one of the reasons why. Now, we know that looking at this chip, we see all these things in here, but question, looking at all of this, do you think this actually has an intermediate frequency? Good question, huh? So what we've done is I set up my little signal generator up here, and it is currently set for 455 kilohertz, as we can see. And I have it connected to my little loop right here. And technically, if this does have an IF of 455, I should be able to pick it up, right? So let's see what happens. And you can see, so we know that this does have a 455 intermediate frequency, don't we? So we know a little bit about how that chip works. Okay? Now once again, let's see if we can overpower that station with my signal generator. So what I'm going to do now is I'm going to go up to about, let's say 1.1 megahertz or 1100 AM. Okay? And let's just see what happens if we get down to 1100 AM, roughly. Okay? Wait till I get this tuned in. Okay, 1100 AM. I should be able to go here. And you can see, once again, no and you can see right on 800 AM, which is where my radio station is. So the dial is accurate. It just has pretty close. The only problem is we just don't have very good adjacent signal rejection, and that's just that's one of the problems with these really cheap radios. Okay, so let's kick over to FM, and we'll put on the antenna here, and let's turn on the other signal generator, and I'll move my little loop antenna over to there, and I am set to 98 FM, and let's see what happens. Okay, certainly not. Here we go. And you can see right around 98 FM, I'm picking it up. Not very good, but it works. Let's see. There you go. You can see how directional that antenna is. So it does work. Now the right thing to do would be to take it outside, away from all my noisy bench things and all the, all the interference that's down here on the bench, or to silence my bench by shutting everything down, which I'm too lazy to do right now. But you can see that the radio will work if you build it. You can see that it wasn't the easiest thing on earth, and once again, that might be a good thing, because it you can work on honing your soldering skills, kind of figuring things out with very minimal, a schematic and a board layout. We learned that some of those components, those capacitors, aren't what they're marked. They don't follow the standards. So all those things we learned from this. So I hope you like this. If you did, give me a thumbs up. And more to come. We got a lot of other little neat projects coming up. I'm sure for some of you this was boring, but maybe for you new to electronics, this was something interesting and you learned something. All right. Thanks a lot.